Despite the noise about uncertainty in the political arena,
Warming will actually save lives, not endanger them.
Do I believe scientists? No!
the fundamentals of climate change have been understood by scientists for decades. To start with, there are naturally occurring gases, such as carbon dioxide and methane in the Earth's atmosphere. In themselves, they aren't bad. In fact, we need them in limited quantities to keep our atmosphere at just the right temperature for life as we know it to exist on Earth. But if we produce an excess of these gases, as we have, the temperature rises, as it has. If you want, you can replicate this effect yourself in a simple lab experiment. Here's how. Take two identical bottles and set them side by side. Put a thermometer in each bottle and seal them. Then run a hose from a source of CO2 into one of the bottles. Shine two heat lamps of equal intensity at equal distance onto each one. Within minutes, you will see the temperature of the bottle with the carbon dioxide in it rising faster and higher. The bottles are like our atmosphere. The lamps are like our sun. Most of the solar radiation reaching the Earth is absorbed by the surface and atmosphere, which in turn radiates energy out toward space as infrared energy, heat. Most of the heat energy from the surface is then absorbed by the greenhouse gases in the atmosphere and radiated back down toward the surface. The more greenhouse gases we create, the more heat is absorbed and sent back toward the surface to cause further warming. This recycled heat does more than bump up the thermometer. Warm air has the capacity to hold more moisture, and water vapor is itself a greenhouse gas. So there's even more warming, which means the planet's entire hydrological cycle, the water cycle, is affected. More evaporation, more precipitation, more extremes in general. For nearly 1 million years, the CO2 content of the atmosphere moved within a natural bandwidth. But during the Industrial Revolution, humans started burning fossil fuels in increasingly large amounts. In fact, now, that's around 7 billion of us, rely on carbon-based fuels for 85% of our energy. Humans currently produce around 35 billion tons of carbon dioxide every year. About 55% of that is absorbed by the ocean, land, and vegetation, while the rest remains in the atmosphere. Most of that excess comes from burning fossil fuels. And more than half of the emissions come from power plants and factories, while about a third comes from our various forms of transportation. If we continue the current trajectory, by the time our children reach middle age, the levels of atmospheric CO2 will reach twice that of our planet's long-time natural levels. That is why we're already seeing the temperature increase, and we're already seeing the consequences. 4% more moisture in the atmosphere above the ocean is enough to transition to a new normal. Dramatic weather events, floods, storms, droughts, fires, they're all happening at a frequency and intensity we've never experienced throughout human history. In other words, climate change. We've set this chain in motion, but the truly cataclysmic changes can be prevented if we act now.
Carbon dioxide is not a harmful gas, it is a harmless gas.
The first step is to separate fact from fiction. This climate science is no longer a matter of opinion, politics, or dogma. So let's not let a few dirty energy companies fool us or slow us down. There are now increasing numbers of affordable, clean tech energy sources, all available to us in limitless supply. By embracing them, we will create jobs and improve the economy. The current climate crisis is reality. We can't wish it away. What we can do is cease the debate and the denial and move on to solutions together.
Lately, we've been hearing a lot about global warming, and words like carbon footprint, climate shift, carbon dioxide, and climate change. But what is carbon? And what does it have to do with climate change? Carbon is everywhere in the ecosystem, and it is always moving. Some of it is floating in the atmosphere. Plants absorb carbon from the air and store it in their bodies. When animals eat plants, they eat carbon. And when something bigger eats those animals, they're having a carbon snack too. But that carbon won't stay still for long. When an animal poops or something dies, carbon moves around again. Some of it is held in the soil for a while. And eventually, most of it ends up back in the atmosphere. The same type of process happens in the oceans too. Most of the carbon dioxide gas on Earth is actually dissolved in ocean water. Some of the carbon from dead plants and animals was trapped underground, and over millions and millions of years, it turned into coal, oil, and gas. And that's pretty much how the system works. Some carbon has stayed deep underground for millions of years, but the rest moves around the ecosystem from the air to plants to animals and back into the atmosphere. And that's the story of the carbon cycle. Well, it was, until we came along. We've been cutting down a lot of forests that used to absorb carbon from the atmosphere. And we've been digging up carbon from deep underground and burning it for energy. Doing that pumps that old carbon back into the air. By getting rid of plants and burning lots of fossil fuels, we've changed the system. The atmosphere is filling up with carbon faster than plants and oceans can absorb it. All this extra carbon in the air is like a blanket around the Earth that traps in extra heat from the sun. And things are changing all over the globe. But now that we know that we are part of the system, we can do things to keep it in balance. We can stop chopping down forests and plant trees. We can use less energy. Even better, we can find other sources of energy and leave the ancient carbon underground and out of the atmosphere.
One of the most exciting scientific findings of the past half-century has been the discovery of widespread trophic cascades. A trophic cascade is an ecological process which starts at the top of the food chain and tumbles all the way down to the bottom. And the classic example is what happened in the Yellowstone National Park in the United States when wolves were reintroduced in 1995. Now, we all know that wolves kill various species of animals, but perhaps we're slightly less aware that they give life to many others. before the wolves turned up, they'd been absent for 70 years, that the numbers of deer, because there was nothing to hunt them, had built up and built up in the Yellowstone Park, and despite efforts by humans to control them, they'd managed to reduce much of the vegetation there to almost nothing. They'd just grazed it away. But as soon as the wolves arrived, even though they were few in number, they started to have the most remarkable effects. First, of course, they killed some of the deer, but that wasn't the major thing. Much more significantly, they radically changed the behavior of the deer. The deer started avoiding certain parts of the park, the places where they could be trapped most easily, particularly the valleys and the gorges. And immediately those places started to regenerate. In some areas, the height of the trees quintupled in just 6 years. Bare valley sides quickly became forests of aspen and willow and cottonwood. And as soon as that happened, the birds started moving in. The number of songbirds and migratory birds started to increase greatly. The number of beavers started to increase because beavers like to eat the trees. And beavers, like wolves, are ecosystem engineers. They create niches for other species. And the dams they built in the rivers provided habitats for otters and muskrats and ducks and fish and reptiles and amphibians. The wolves killed coyotes, and as a result of that, the number of rabbits and mice began to rise, which meant more hawks, more weasels, more foxes, more badgers. Ravens and bald eagles came down to feed on the carrion that the wolves had left. Bears fed on it too, and their population began to rise as well, partly also because there were more berries growing on the regenerating shrubs. And the bears reinforced the impact of the wolves by killing some of the calves of the deer. But here's where it gets really interesting. The wolves changed the behavior of the rivers. They began to meander less. There was less erosion. The channels narrowed, more pools formed, more riffle sections, all of which were great for wildlife habitats. The rivers changed in response to the wolves. And the reason was that the regenerating forests stabilized the banks so that they collapsed less often, so that the rivers became more fixed in their course. Similarly, by driving the deer out of some places and the vegetation recovering on the valley sides, there was less soil erosion because the vegetation stabilized that as well. So the wolves, small in number, transformed not just the ecosystem of the Yellowstone National Park, this huge area of land, but also its physical geography.